Functions, page 3. So draw a picture of a function machine. If you look on page 57, there's a picture of a function machine. But basically, it's like, and you've seen these before. They have them in your elementary books and in your 9th and 10th grade math books. But basically, you have an input, okay, x, and then you have an output, y, and then you have the function machine itself, which is f of x, something like that. Another way to write it is like this, where you have f colon x goes into the function machine, out comes 2x plus 3. What are two other ways to write this function? So one of them is y equals 2x plus 3. That one you've seen quite a bit. And the other one is f of x equals 2x plus 3. All right. Which terms refer to f of x? So f of x, it's the function value, it's the y, it's f of x, function output. Okay? Also image of x. These are all ways to refer to f of x, as you can see in the page 58 reading. Write an example of a linear function f of x. I could say f of x equals 2x plus 1. What shape is a linear function graph? Well, it's a line. Evaluate your linear function for f of 1 and for f of x plus 1. So first I'm going to take the x and I'm just going to put in 1. So it's going to be 2 times 1 plus 1, which is equal to 4. Next thing I'm going to do is I'm going to evaluate it for x plus 1. So instead of putting in 1, I'm going to put in x plus 1. This is a little bit confusing because you're putting the x plus 1 in for the x there. And they're not the same thing. This x here is an input. This one's an input. But this x here is just like the function machine input. And so this x is not the same thing. It's very confusing that we're putting x in there again. Maybe what you could think of it as, it's not really 2x plus 1, it's 2 blank plus 1. And then you just put in x plus 1 in the blank, just like you put 1 in the blank. Okay? So then you get 2 times quantity x plus 1 plus 1, and if you multiply that out, it's 2x plus 2 plus 1, so it's actually equal to 2x plus 3. Right? Okay. So we wrote an example of a linear function. We said that the shape is a line, and then we evaluated it for 2 possible inputs, 1 and x plus 1. So it's interesting that the input does not have to be a number. The input could also be another function. Okay. So for this function here, 3x plus 2, find the value of, and then they give us a few x's that they want us to put in. So it would be 3 times 0 plus 2 is 2. 3 times 2 plus 2 is 6 plus 2 is 8. 3 times negative 1 plus 2 is equal to negative 3 plus 2, which is equal to negative 1. F of negative 5, so it would be 3 times negative 5, which is negative 15, plus 2 is negative 13. Negative 1/3, so negative 1/3 times 3 is negative 1, plus 2 is 2. No, wait, negative 1 plus 2 is 1. Okay. Next function, 3x minus x squared plus 2. Find the value of that. So if you put 0 in for that, you're just going to get 0 minus 0 plus 2, which is 2. If you put 3 in for the x's, you're going to have 3 times 3 is 9, minus 3 squared, which is 9, plus 2, you still get 2 again. What if you put negative 3 in? Then you would have negative 9 minus 9 plus 2, which would be negative 16. What if you put in negative 7? It would be negative 21 minus 49 plus 2, which would be about 72. Okay, and then finally 3 halves. If we put 3 halves in there, it would be 3 times 3 halves minus 3 halves squared plus 2. So it would be 9/2 minus 9/4 plus 2. So it would be 9/4 plus 2, which would be 17/4, I think. 17/4. Okay. X minus 4 divided by x. If we put 1 in there, it would be 1 minus 4, so it would be negative 3. If we put 4 in there, it would be 4 minus 4 divided by 4, which is 4 minus 1, which would be 3. If we put negative 1 in there, it would be negative 1 minus 4 divided by negative 1. So the second term would just be 4, and the first term is negative 1, so that would be 3 also. Put negative 4 in there, it would be negative 4 minus 4 divided by negative 4, which would be 1. So negative 4 plus 1 is negative 3. Would have put negative 1/2 in there. Then it would be negative 1/2 minus 4 divided by negative 1/2, which would be 1, something like that. So negative 1/2 plus 8, which is going to be 7.5. Okay. The input of A is just going to give 7 minus 3A. The input of negative A is just going to give us 7 plus 3A. A plus 3 in for that is going to give us 7 minus 3 times A plus 3. We can multiply that. We got 7 minus 3A minus 9, which is equal to 7, it's equal to negative 3A minus 2. Here we got B minus 1 going in there, so we got 7 minus 3 times B minus 1. So 7 minus 3B plus 3. So it's equal to 10 minus 3B. What if we put x plus 2 in there? Then we have 7 minus 3 times x plus 2. We can simplify that. We get 7 minus 3x minus 6. So it's 1 minus 3x. Last one. 7 minus 3 times x plus h. And there's not much you can simplify here because they're just constants here. Something like that. Okay. 5a. We got this function. Find in simplest terms. So we're going to substitute in x plus 4 squared plus 3x plus 4 minus 1. So this one's going to be 2x squared plus 8x plus 16 plus 3x plus 12 minus 1. 2x squared plus 16x plus 32 plus 3x plus 12 minus 1. So let's see, let's combine like terms. So 12 minus 1 here and 32 here, those are like terms. 16x with 3x, those are like terms. And 2x squared all by itself. So we'll have 2x squared plus 19x, and 32 plus 12 is 44, minus 1 is 43. What a mess. Okay, so that was for A. What about for B? They're going to give us 2 minus x. So we're going to have 2 times 2 minus x squared plus 3 times 2 minus x minus 1. 2 times 4 minus 4x plus x squared plus 3 times 2, which is 6, minus 3x minus 1. Now we'll combine like terms. 6, negative 1, and oops, I didn't multiply it all out yet. So 8 minus 8x plus 2x squared. I'm going to combine the 6 and the 1. I'm going to get 5 minus 3x. Now I'm going to combine like terms. So negative 3x combines with negative 8x, and 5 is going to combine with 8, and 2x squared is by itself. So 2x squared minus 11x plus 13. That was that one. What about negative x? Oh, finally a little bit of relief. That one's not too bad. So we'll have 2x squared minus 3x minus 1. And that's it. What about x squared? That's not too bad either. So 2x to the 4th plus 3x squared minus 1. You see what I'm doing? I'm just replacing the x with whatever's in the parentheses. This one's kind of a mess. This would be 2 times x squared minus 1 plus 3 times x squared minus 1 minus 1. So 2x squared minus 2 plus 3x squared. Oops, I forgot the squared here. There's a squared there. Even worse. 2 times x to the 4th minus 2x squared plus 1 plus 3x squared minus 3 minus 1. Now we're going to multiply it out. 2x to the 4th minus 4x squared plus 2 plus 3x squared minus 4. Now we'll combine like terms. Negative 4 combined with 2. 3x squared combined with 4x squared. And 2x to the 4th by itself. So 2x to the 4th minus 1x squared minus 2. Okay. Now, last one, x plus h. So that'll be 2 times x plus h squared plus 3 times x plus h minus 1. So this will be 2x squared plus 2xh times 2, which would be 4xh, plus 2h squared. And then we're going to add the others to it. So plus 3x plus 3x plus h plus 3h minus 1. And there's not too much you can combine here. We just leave it like that. If you wanted to, you can combine like the x terms. You could have 2x squared, and then you can combine this with this, so it would be 4h plus 3, 4h plus 3x, and then you would have plus 3 plus 2h squared plus 3h minus 1. But that's not really improving it that much, right? That was page 3.